Now in math, it's a bit different. We also have 3 standards in math, and if we could kind of describe the state of affairs in math education in this country, it is often described as a curriculum that is a mile wide and an inch deep. An associate of ours who is still teaching 4th grade calls it the spray and pray approach to teaching math. We just give kids everything there is and hope some of it will eventually stick. And so when I think about equivalence between mathematics and literacy, which I usually hesitate to make those connections, if our strategy with struggling readers has been then just give them something easier to read, our strategy with kids who struggle with math is we just tell them to hold on till Monday because we're starting something new on Monday. You know, you don't understand how to add and subtract, don't worry, we're going to teach money on Monday. Don't worry, we're going to do this the next day. And we don't really take time within the math world to help kids build kind of the thing I really do pray for our kids, confidence in math. It is true that there has been a significant amount of research in math curriculum and math education, and just an interesting thing to note, that it is only in this country that we believe that kids are born good at math or not. I mean, I remember as a teacher and I taught science, how many parents would say, oh, you know, see, I wasn't really a math or science student, so my kid's not really going to be a math or science student. And it turns out most other countries believe that the way you get good at math, you just do math. You practice it. And so in my own district, I am relatively anonymous, just recently kind of letting my presence be known. But when I went to my daughter's 3rd grade open house last year, I just can't even tell you how often the teacher said, so 3rd grade, math, it is tricky, really tricky. Don't worry about it, but it is tricky. And can you imagine, like, no wonder our kids kind of like go through elementary school saying, yeah, math, that's hard. That's not for all of us. That's just for the wizards. Like, we're not supposed to understand this stuff. But the way our curriculum is laid out, it makes it quite obvious. I was sharing before the presentation that last year when my daughter was in 3rd grade, I took a month and I scanned her homework every night for a month and created a PowerPoint slideshow about it. And it was almost funny, again, if it wasn't true, how quickly we went from counting cupcakes to telling time to counting money to, okay, maybe there was a little multiplication. I mean, it was just crazy how we have approached math education. So thinking about the 3 shifts in math, the first one is focus. And this is probably the first time in a really long time, if not ever, that we start an education initiative with the conversation that starts with, here's what we need to stop doing. Everything we've ever done in education is as if we weren't already working at 110%, and here's one more thing to do. The Common Core by design starts by saying we need to figure out how we are going to make time and space in our curriculum to really support all students meeting these higher expectations. And so one of the things that we get with Common Core state standards is this idea of we focus on fewer things, but in depth, absolutely in depth. And so here is what math typically looked like. I am telling you, in every state in this country, I can put this slide up there. And so kindergarten through 12th grade, we do a little bit of numbers and operations, a little bit of patterns and algebra, geometry and measurement, statistics and probability, every single year. Every single year we do this. Even though we know, if I ask any K2 educator, of these 4 things, what is the thing that you really think you need to focus on? And it is always, always true. Doesn't matter how contentious the audience might be, they always say it's numbers and operations. But it's not what our curriculum shows. It is in there, just like, you know, that whole Wendy's commercial, it's in there, but it is not the major concept of what students are focusing on. So what we want to see is greater depth on those major topics that matter. And so what this looks like in the standards, and this might be a bit hard to see, is that in K2, we're focusing on fewer things. Kids are really going to understand the concepts of number because we're not racing through. You know, we had an interesting dinner conversation where I was talking to one of your residents here who works in early childhood mathematics, and just having kids understand the concept of the very simple numbers, we just kind of gloss over that. And we right away skip to bigger numbers, not understanding how kids developmentally get good at that. I'll give you a great example. One of the things that we took out of early elementary math standards is the study of patterns. So you probably have all experienced this either as a student or as a parent, where kids come home and it's blue circle, red square, blank, and we do this. And so it turns out kids are really good at this. As my mom, who's a third grade teacher, tells me, but kids like it. They're good at it. And we took it out of the standards because it's not math. It's actually a strategy. And in my own state of New Jersey, and I was at the department at the time when we were contemplating the standards, the math professors in the state went crazy over this. You cannot take patterns out of the standards. Kids need that to get ready for algebra. It's like finding the missing variable. And so I called the math authors up who I had already met at the time. I said, oh, what do I tell this math professor who's telling me you need this? Just tell them to look at the evidence. Patterns happens to be the only topic that US is #1 in the world in. We are not #1 in the world in algebra. We are really good at it. Kids like it. It puts a smile on their face, but it does not help them with what we need them to be able to do. So one of the things that happens once you get to focus, so if you can imagine what's happening with this idea of focus, is that we are actually taking a look at our curriculum and figuring out which things just go away. They go on to middle school instead of elementary school. They go on to later times when kids can actually develop them. Another great example, just sharing parent to parent. My daughter in 2nd grade brought home a worksheet just last week where they're learning how to read temperature on a thermometer. And one of the temperatures that they had to read was 20 degrees below 0. A 2nd grader has no concept of what below 0 means, right? I mean, nobody thinks about that. It's just what the worksheet says, so they can do that. But the idea of building math to make sense is very different. And so this idea of when we learn math, we actually make these connections is really important. So last year when my older daughter was in 3rd grade, I decided to give her the greatest gift a mother could give a child, which was to require that she know her multiplication facts. Whatever the teacher was going to do or not do, I knew, having been a teacher, having been a principal, when you're that kid that knows your multiplication facts, you have an advantage in your science classes, in the rest of your math classes. It is the gift that keeps on giving. So we decided that we were going to spend some time and energy focusing on that. And it turns out, by the way, that as long as you just make that decision, do the flashcards, it's not such a hard thing to do. You just need to set a value for doing that and then go ahead and do that. And so we did multiplication. She made it through. She got the things necessary to do it. And then I remember being at the bus stop with her Monday morning, and she goes, Mom, guess what? Today we're doing division. And I will tell you, I just kept saying, oh, when she gets off the bus today, she is going to be so glad she knows those multiplication facts, because all those other kids that didn't know them, they would be struggling through division. But if you know multiplication, you know division. I mean, it's the same thing, right? So she comes home, and I said, so how did it go with division? She goes, so we had this problem, Mom, and it was 45 divided by 5. And so what the teacher had us do is take 45, subtract 5, subtract 5, subtract 5, subtract 5, and they teach it, and places do this all the time, as repeated subtraction. She goes, takes up a lot of paper, Mom. But the teacher could not teach it as the inverse operation of multiplication because she couldn't be assured that every kid in that class knew their multiplication facts. So we teach it as it's a new topic, something absolutely distinct from what they've learned before. So what the standards allow us to do, or actually expect us to do, is to actually make those connections from year to year and from topic to topic within a grade. And so this is kind of an example of previously taught, and I don't know how well you can see this green stuff here. This is the progression of fractions. So one of the features of the standards that, the nerd in me wants to say is just so beautiful is that we build from grade to grade to grade. So this is fractions, which, by the way, is the thing that predicts students' success in algebra and therefore future math beyond that, is how well they can understand and manipulate fractions. So previous state standards would have just said something like, by the end of 6th grade, students can perform operations with fractions. Very different from the way these standards are laid out, where in 4th grade, you start off by multiplying a fraction with a whole number. That's the in-depth thing that all kids need to know really well. All kids need to know really well. So then by 5th grade, the expectation changes to multiplying a fraction or a whole number by a fraction. It advances again in 6th grade, where you're multiplying and dividing fractions by fractions. Versus what we used to do is just kind of put all that stuff in one expectation at the end of the grade and didn't really consider how these things develop over time. Another third part, last of the 3 shifts in math, is really going to probably be what looks most significantly different in the math that your children are bringing home to you. There has been this interesting false choice that we typically have in curriculum programs between, so what do you think is more important? That kids understand math, or should they be able to get the answer right? And it has been kind of this thing that in some states have actually caused significant, what we typically call the math wars. Like, is it about conceptual understanding? Is it about procedural skill in mathematics? And within the Common Core state standards, all 3 things are important, and all 3 things deserve the time and attention in classroom situations. So here is an example of what we typically do in teaching a very important concept in early elementary, place value. And so you can find worksheets upon worksheets upon worksheets where kids fill out answers like this. I am absolutely certain that you all have experienced this kind of problem in your kids' math, where it's numbers and numbers and numbers, where it's blank hundreds, blank tens, blank ones. And kids figure this out pretty soon. First number goes in the first spot, second number goes in the second spot, and they know nothing about place value. It becomes what? A pattern problem. And so we do these, teachers feel good about it, kids are getting 100% about it, but they're not really understanding the concept. Very different than the type of math problem that asks students to actually show their concepts. Something like this: 14 tens. Is 10 tens and how many more tens? More rich examples that actually go after conceptual understanding. Another example that I typically like to use, more 3rd grade math. Write a number between a 5th and a 4th. Give me a fraction between a 5th and a 4th. Ask students that question, and you get a sense that they really understand the concept of fractions. And just to say, because it's good cocktail humor, 37% of adults surveyed said there is no such number. Right? Because they know how to find common denominators, add things up, but do they really understand the concept of a fraction? Ask them what a number is between a 5th and a 4th, and you know whether they know that or not.